In chapter 2, we'll begin the study of logic. And in section 1, the focus is to introduce the fundamentals. So we're going to talk about logical form and some important results, which is the logical equivalences. And first of all, let's introduce the logical form. In chapter 2, we'll begin the study of logic, the logic of compound statements more specifically. This is called statement calculus or propositional calculus. In the first section, we'll study the fundamentals. So it includes what is a logical form, and there are some terms and symbols we'll be using for the rest of these units. And we'll also learn how to construct truth tables and study some important results, including de Morgan's laws and all the logical equivalences listed in theorem 2.1.1. And let's begin with some terms. Argument is a sequence of statements aimed at demonstrating the truth of an assertion. There's a valid argument, there's an invalid argument. In this section, we'll learn how to determine whether an argument is valid or invalid. And there are, in the future sections, we'll also learn more of valid and invalid form of arguments. Conclusion is the assertion at the end of the sequence. And premises is that there are the preceding statements to the conclusion. So all the statements before the conclusion, that's called premises. Now, one big comment is we'll focus on the form of arguments, not the contents of arguments. So soon I'll give you one example that contents is not the focus. Here we'll focus on the form of arguments. Some symbol like 3 dots like that, that means therefore, and 3 dots like that, that means because. So we'll be using those notation. In logic, we use lowercase letters to represent parts of the arguments. Now I'm going to begin with the first example, and then we're going to see how we actually identify the form and how we use letters to represent some part of the arguments. So let's take a look at the first statement, okay? Here, identify the form of the first argument and use it to obtain the conclusion of the second argument when they have the same argument form. So now take a look at the first statement. If Dave goes to swim daily, or if it rains today, then Dave knows how to do proof. Take a look at this statement. We see that this is a kind of like small part of the argument. This is a sentence. This is a statement, swim daily. And this is another one, it rains today, right? And Dave knows how to do proof. That this is the third kind of statement in this first argument. Now, therefore means the conclusion, right? All these are called premises, okay? Therefore, if Dave does not know how to do proof, if you feel like, you probably feel like we have read something already very close to that. Yes, you're right. So this is very closely related. Here, this says he knows how to do proof. Here, he doesn't know how to do proof. This is kind of like opposites of each other. So now I'm going to introduce a letter to represent each part of the argument. So I'm going to let P represent Dave goes to swim daily, and let Q represent it rains today. So it doesn't include the if, okay? Just it rains today. It rains today. And then R represents Dave knows how to do proof. And therefore, if Dave does not know how to do proof, this basically is like not this guy, right? So I can say not R, Okay, it's not the case that Dave knows how to do proof. Okay, so in logic, we are going to use this symbol like not, like a little squiggle, like this one, not R. Okay, not R. This is the notation we're going to use. Then he doesn't know. Then he doesn't go to swim daily. So if you look at this, doesn't go to swim daily, that's actually opposite of this guy, right? Not opposite. That means not P. So we're going to use not P. And there's an and. This is all, but this is and now. And it doesn't rain today because we already defined it rains today as Q. So it doesn't rain today. That will be not Q. Now, if you look at the contents, this content is a kind of like absurd. It's ridiculous because certainly if Dave goes to swim daily or if it rains today, then he knows how to do proof. That knowing or not knowing how to do proof has nothing to do with these, right? So here we are just focusing on the structure, the form. We call it form. We don't actually pay attention to the contents. You can create any ridiculous statement as you want, but we focus on the structure. So if I summarize what I see, this is what I see. The premise here is if P or Q, right? If P or Q, then, so this is a conditional statement, then R. Now take a look at the conclusion. The conclusion is therefore, if, now take a look at the conclusion, if not R, so not R, then you can pause my video and see if you are able to identify the form. Then not P and not Q, okay? Not P and not Q. So that's the form we are talking about. That's the structure of the first argument, the argument presented here. Now, if we assume that these two arguments, they have completely different contents. Now, if you are told that they have the same argument form, I would like you to give a try to see if you are able to fill out the blanks and then using the information presented in the premise right there, okay? So again, I encourage you to pause the video and then give a try before you move on. Okay, now let's continue. So let's take a read this. If x less than -2 or x greater than 2, so I'm gonna call this as, this is my P, this is my Q, then this is my R. Do you see that? It is this form, if P or Q, then R, right? Now, according to previous structure of the conclusion, then we should say if not R. So I'm gonna, if not R. So if this is supposed to be not R, so that means not this guy. What is the opposite of, so I'm gonna write this down, if not x squared greater than 4, which is not R, right? Then according to the structure here, not P and not Q. So it's not P, not this guy. So it's not x less than -2 and not Q, x and not x greater than 2. So of course, oftentimes we don't just write it. We have a better way to write the conclusion. If not, well, I'm sorry, not x greater than x squared greater than 4, that means x squared less than or equal to 4, right? Then not x less than -2, that means x greater than or equal to -2, and not x greater than 2, that means x less than or equal to 2. So the common form of these two statements, they both have this form, okay? This form, this is the form that we are gonna we're going to look at. So we want to be able to identify the form. That's the first learning objective. So pause a moment and do a little reflection to see if you have any question or something that you don't understand. That would be a good moment to review the video. Let's move on to the next one. So you're given that both arguments have the same form. Fill in the blank. So we are gonna repeat what we have done. So let's first identify the form. So if all integers are rational, so let's call this as P. Then the number 1 is rational. Let's call this as Q. Okay. Now the second statement is saying all integers are rational. It seems like this is identical to this one, right? So therefore, I see a P repeated, P statement repeated. And therefore, the number 1 is rational, and which is identical to this guy. So Q is repeated. In other words, the form I see is if P then Q. The first premise is that. And the second premise is P, okay? And what's the conclusion? Therefore is the conclusion, therefore Q. So that's the form we observe from the first argument. So this is the form. So let me highlight it. Okay. Now, because we do know that these two arguments have the same form, let's apply this form to the second argument. Okay, so the form says if P then Q. So therefore, I know this has to be my P. This is my P. This is my P. Then Q. This is my Q. And the argument says the next statement is the P. So therefore, I know the next premise is all dogs are killed. Okay, and the conclusion says therefore it has to be Q. So now we don't know what this is, but because the result is supposed to be Q, so I know what Q is. So the Q has to be it will rain tomorrow, right? It will rain tomorrow. Now, one more time, I hope that you recognize this argument is completely ridiculous. It's absurd because all dogs are killed and it will rain tomorrow. Raining or not raining has nothing to do with the dogs being killed or not. So again, we focus on the form. We don't focus on the contents. And these two arguments have the same form. If this argument is valid, then this argument is also a valid argument. We call the form is valid. Now, we're going to continue. There were 3 initial undefined terms. I hope that you understand why we have to have undefined terms. Oftentimes, we define some term using other terms. Like here, we define arguments, conclusion, premises using English words, right? But you know, in order for you to continue, you can imagine if you define something again using other words, eventually you will reach to an end that there has to be some words that you cannot define them anymore using other words. So the end of the chain, we call it undefined terms. And these undefined terms are sentence, true or false. So how do you define true? Something you're running out of words. So true is undefined. We know what true is. We just probably make some spiritual mutually agreement. So hopefully you know what true is and what false is. And sentence is just a sentence. Now, statement or a proposition is a sentence that is either true or false. You see, we begin to define statements. Statement is defined using all those 3 undefined terms, okay? So a statement cannot be both. it's either true or false. You can tell it is true or false, but it cannot be true or false at the same time. Now let's take a look at 1 plus 3 equals 5. Is that a true statement or false statement? I hope that you do recognize 1 plus 3 is actually 4. 4 is not the 5, right? So therefore, this is incorrect. So that means it's a false statement, false. And because you are able to tell it is false or true, so therefore it is a statement and it is a false statement. So it is a statement. Now x plus 1 equals 2. Is this a statement? Then you just ask yourself, is that true or false? Some of you say, well, when x is 1, this is true. But when x is other values, then this is not true, right? It really depends on what this x is. So therefore, you cannot tell specifically whether it is true or false. It really depends. So sometimes true, sometimes false. So we say it cannot be both. So therefore, this is not a statement because it's sometimes true, sometimes false, not a statement. Because sometimes true, sometimes and false, right? So therefore, it cannot. Third statement, Dr. Huang teaches math. Well, I have been teaching math all the time. If you want to argue like this is a computer science course, but actually this the title of the book is Discrete Math. It's considered a math course sometimes. So I'll say this is true. Okay, this is true. Or if you argue, hey, this is not what I'm teaching here, this is not a math course, then you would consider it false. If we all agree that this is not a math course, then this will be a false statement. But the thing is, we can for sure, once we build the criteria, we can identify whether this is true or false statement. It cannot be both, right? So therefore, this is a statement. And he is a student. What about this one? Well, this really depends on what he is. So if for you, he means Dr. Huang, then I'm not a student, I'm a teacher. If you refer to a student in the classroom, then he is a student. He is a statement. So this really depends on he. So therefore, sometimes true, sometimes not true, just like this statement, we are going to say this is not a statement. The reason is just like the same as this one. Okay, so that's the very fundamental one. The next, we are going to introduce connectives. What are the connectives? They're the words connecting simple statements so that we form more complex statements, which is called compound statements. So there are 3 very fundamental ones we are going to introduce. There are more in the future. So the first we are going to introduce is the not. We have experienced the not right there, right? So because the not right there, we experience that. This is called negation, okay? Negates, it's opposite. And the symbol we are going to use is, in our book, is just this symbol. And in many other computer science book and some other textbook, sometimes they use this symbol as well. Just be aware that both could be used. But we're going to use the first one. And we also saw the and right there. This is and. So it connects 2 simple statements. And it's a conjunction. We use this symbol, this triangle, like the tip. And or is the disjunction. We use this like V shape, okay? So this is upside down V shape. This is the V shape. The order of operation for these connectives, not is performed the first. So this has the first priority, but it can be overridden by parentheses. So just like 2 times 2 plus 1, right? So this 2 has the priority, but when you put a parenthesis there, the parenthesis override the order of operations. So that's the same idea. N and O are considered co-equal. So now N and O are considered co-equal. However, P, O, Q, and R should not be used, should be avoided, because this is considered ambiguous. So to avoid this ambiguity, we use parentheses to write it's either this one or that one. You don't write this one. So be careful on that. Now let's take a look at another example. Statements involve but and neither nor. In logic, the English word but means and. I hope that makes sense. Like for instance, the first example, John is not healthy, but wealthy. So here, John is not healthy, and you want to say, emphasize, hey, he actually is wealthy. So this is actually happen at the same time, right? So this but is the same as and John is wealthy at the same time. So but means and. Phrase, the phrase neither A nor B. How do we translate that in the logic? Neither A, that means not A, nor B. So and at the same time not B, right? And at the same time not B. So that's how we would translate neither nor into logic. Okay, the next objective is to, so oftentimes we use lowercase letter to represent some part of the argument, part of the statement, and then to form a more complex statement, which is called compound statement. So we are going to translate, use symbol to represent statements. So now let's take a look at the first one. John is not healthy, but wealthy. So the but means the and, right? Not healthy. So we define healthy. John is healthy as H. So it says not healthy, that means not H. But means and. So we are going to use the upside down V, the and symbol. And wealthy, W means John is wealthy. So and W. So not H and W. Do we need parentheses? We don't, because we do know that not, the negation, has the first priority. So we don't need the parentheses to overemphasize. It has the first priority. So this is completely fine. But if you say this, that will not be considered wrong, but I just feel like it's a little redundant. So this is redundant. Usually we don't write that, okay? Now, the second one is John is neither wealthy nor healthy. So we already mentioned neither A nor B. That means A is not occurring, B and at the same time, B is not occurring. So therefore here, wealthy is not occurring. That means not wealthy, not W. And at the same time, not healthy, so not H. So that's how I would write that into symbolic form. Parentheses are not necessary, again, for the same reason. And we also want to make sure that we know how to translate the inequality into using the correct connectives. So if you read, this one is pretty natural. If you will read X is less than or equal to A, right? So therefore you hear the or, you use this V. This is the or symbol. So this is how we represent this inequality into two expressions connected with the or. Now this one, when we read, is X greater than or equal to A and less than or equal to B. That's how we usually read. So you see that X is greater than or equal to A and which is this symbol, or you can use word and, x is less than or equal to b. Okay, so that's how we treat inequality, or write the inequality into connected by the connectives. Okay, exercise. Let P be, let's don't let it block the expression. So let P be 0 less than x, or x greater than 0. So P be this statement. Q be this statement, x less than 3, and S be x equals 0. Let's write the following inequality symbolically using the letters just defined here. So this is saying x less than 0 or equal x less than or equal to 0, right? So that means x is less than 0 or x is equal to 0. And x is less than 0. Do we see any x less than 0? Well, we do see that x is so we do see that this is x greater than 0, okay, greater than 0. And this is, actually, I feel like in this case, I may overcomplicate it. So if you look at, this is not the case, right? So this is not the case that x is greater than, this is not the case that x is greater than 0. So actually we just say not p, not p. Otherwise it can be a little, so I'm not gonna go that route. Just basically observe that this is just opposite of this guy. So it's gonna be not p. And for the second one, x is greater than 0, which is right there, right? And this is 3 parts inequality. We interpret it as and. There's a typo here. This is supposed to be 3. So therefore, this is x greater than 0. And at the same time, x is less than 3, not 30. So this is my P. And this is my Q, right? Q. Okay. The last one is x is greater than or equal to 0, and x is less than 3. Now we do have x less than 3, which is Q. For x greater than or equal to 0, again, this guy is, let's write it one more time. For this guy, this is x is greater than 0, or x is equal to 0, right? Okay. So I hope that when you see how I write it, you want to put a parenthesis to group that one. So we're going to say x is greater than 0, which is the P. Or this is or, so we should use or symbol. X is equal to 0, which is S. So this comes from right there, and is this symbol, and x less than 3, which is the Q. Well, the parentheses here, that's very necessary. You cannot remove that. You cannot erase the parentheses, otherwise this will be considered ambiguous. So you do want to keep the parentheses. All right, this is the first part of this section. I'll